Alright guys, we're going to begin section 1.5 talking about angle relationships. Um, there are going to be additional relationships between angles that are going to be explored in chapter 2. Um, there's a couple different cases of special pairs of angles here, and let's just dive right into them. Alright, as it's stated here, some pairs of angles are special because of how they are positioned in relationship to each other. You're going to see when we get into chapter 2, when we talk about lines cut by a transversal, that there's other relationships there. The first type of angle relationship are adjacent angles. There are two angles that lie in the same plane and that have a common vertex and common side, but no common interior points. All right. So you can see here, if we were to denote this line here, denote these two angles here. Get the pen out here. If we look at this angle here, name it angle 1. This angle here, name it angle 2. There are no common points on the interior of angle 1, and there's nothing common on the interior of angle 2. They only share this side, this ray. So that's what adjacent angles are. They're two angles who share a side but no common interior points. A linear pair, that's a pair of adjacent angles whose non-common sides form opposite rays. In essence, they form a straight angle. So in this case, angle 3 and angle 4, they are adjacent angles, all right, because they share a common side, but their non-common sides basically form a line. All right. The neat thing about linear pairs, the sum of those angles is always going to be 180 degrees. Another type of special pair are vertical angles. They are two non-adjacent angles formed by two intersecting lines. These angles are also congruent. All right, that theorem, that's actually a theorem here. This statement right here about vertical angles, that's a theorem, and we're going to prove it in chapter 2. So if we look here and name these two angles angles 1 and 2, and we name these angles 3 and 4, angle 1 is going to be congruent to angle 2, and then angle 3 is going to be congruent to angle 4. And you'll see in chapter 2 when we prove that that it actually works. And then the last two types of angles, complementary angles, two angles whose sum is 90 degrees, and supplementary angles are two angles whose sum is 180 degrees. Complementary angles and supplementary angles, way to tell the difference between how much do they add up to. Think about the alphabet here. C comes before S. 90 degrees comes before 180 degrees. That's an easy check for that. Alright, so let's do some examples here. Find the measure of two supplementary angles if the difference of the measures of the two angles is 18 degrees. So let's let the measure of angle 1 be x degrees, and the other angle has to be 18 degrees less than it. Alright? These two angles, the measure of the angles has to be 180 degrees because it's supplementary. So the measure of angle 1 plus the measure of angle 2 has to be 180 degrees. Or in essence, x plus x minus 18 equals 180 degrees. We have 2x minus 18 equals 180. And let's solve this equation. We get 2x equals 198. Divide by 2. And you get x to be 99. So if we substitute back in here, the measure of angle 1 is x degrees, which is 99 degrees. And then the measure of angle 2 is 99 minus 18 degrees, or 81 degrees. And those are the measures of those two angles if they are supplementary and their difference is 18 degrees in measurement. Second example, let's find the value of x in the measure of angle SQR. Interesting thing here, these two these two rays here, ray QP and ray QR, they form a 90-degree angle. I know we haven't talked about perpendicular lines yet, but when we get there, you'll learn that these two rays are perpendicular. So think about it. This box means that this angle is a right angle. So together, these two angles, their measure has to equal 90 degrees. So let's go the measure of angle PQS plus the measure of angle SQR has to equal 90 degrees. The measure of angle PQS is 3x degrees. The measure of angle SQR is 8x plus 2 degrees. Alright. And that has to equal, all has to equal 90 degrees. This sum has to be 90 degrees. So let's solve, combine like terms and solve. We have 11x plus 2 equals 90. 11x equals 88. Subtract 2 from both sides and divide by 11. You get x to be 8. Then the last part, find the measure of angle SQR. That's this angle measure right here. Do it over here. Measure of angle SQR. That's going to be 8 times 8 plus 2. 8 times 8 is 64. Plus 2 degrees is 66 degrees. Fix that degree symbol there for a moment. Didn't like how it was shown there. Alright, so that's example 2. Find the value of x in the measure of angle SQR. Remember, these two angles here, they are complementary because of this right angle symbol here. Their sum has to be 90 degrees. The substitute in part is probably the easier of the two parts here. The setup for this is probably a little more difficult than this part here in the solve. In the last example, we have solve for P, and then find the measure of angle ABC. Alright, this measure of 5P plus 28 degrees is this angle measure right here, and 12P is this angle measure right here. Remember, vertical angles, they're congruent. Alright, so you set them equal to each other. Alright, so the measure of angle DBE equals the measure of angle ABC. Alright, so we have 12P equals 5P plus 28 degrees. Subtract 5P from both sides. You get 7P equals 28. Divide by 7, and you get P to be 4. Then the last part is find the measure of angle ABC. So the measure of angle ABC, that's a simple substitute in. Right. P is 4, so we'll substitute 4 in for P. Right. 5 times 4 is 20, plus 28 is 48 degrees. So the key to this problem is that the fact that vertical angles are congruent, so you set them equal to each other, and then you can figure out the rest of the problem. Alright. If you need to stop and take a breather here, go for it. We're around 10 minutes into the video. I'm going to continue on with the last bit of notes and information for this section. Alright. I kind of alluded to this earlier in problem number 2. Line segments, arrays that form right angles, they are perpendicular. That's a vocab term that you should know throughout the course of the year. 4 true statements about perpendicular lines. Perpendicular lines intersect to form 4 right angles. Perpendicular lines intersect to form congruent adjacent angles. Segments and rays can be perpendicular to lines or other line segments and rays. And the right angle symbol in the figure indicates that lines are perpendicular, or line segments and rays are perpendicular. The symbol for perpendicular is basically like an upside down capital T. Alright, that tells us that if we have, say, line L and line M, and the direction said L is perpendicular to M, then we could assume that that's the case, that they form right angles. Okay? So one example here, find the values of x and y so that MQ, line MQ is perpendicular to line NR. Let's start with x first. Alright. These two lines you want to be perpendicular. Alright, so let's solve for x first. That means that the measure of angle NSP plus the measure of angle PSQ has to be 90 degrees. Alright, because by the angle addition postulate, the measures of these two angles together makes the measure of angle NSQ. We want that angle measured to be 90 degrees, especially since we have this right angle symbol. That's what we want to happen. So in order for that to happen, these two angles have to have a sum of 90 degrees. So the measure of angle NSP is not 6x. I'm getting a little bit ahead of myself here. Alright, let's get the eraser real quick. The measure of angle NSP is 5x. The measure of angle PSQ is x. And together their sum is 90 degrees. 5x plus x is 6x. That's where I was getting the 6x from earlier. Equals 90 degrees. Divide and you get x to be, divide both sides by x and you get x to be 15. So that's the first part. Solve for x to find if MQ and NR, line MQ and line NR are perpendicular. And then the last one is solve for y. So in that case, we're going to say the measure of angle MSR is equal to the measure of angle MSN, which is 90 degrees. So I'm going to replace this side here in the green with 90 degrees again. The measure of angle MSR is 9y plus 18 degrees. That has to equal 90. We'll subtract 18 from both sides. We'll get 9y equals 72. And then if we divide both sides by 9, we'll get y to be 8. And those are your two answers for that problem. Alright, so those are the basic angle relationships that we're going to talk about right now. In a few sections we'll get to transversals and stuff later in chapter 2 after we talk about theory and proofs a little bit and conjectures and counterexamples, but for right now just know these 5 or 6 types of special angle pairs, special angles, including perpendicular lines, and all that jazz. Okay? Couple problems for you to work on after you watch this video, right about the 15-minute mark. 7 problems. They're on pages 50 and 51, numbers 1 through 7. Let me look at those problems real quick while I have the book in front of me. Alright, they are not at all terribly bad. Number 6 and number 7 might give you a little bit of a hard time, but think about your definitions of complementary angles, adjacent angles, and supplementary angles. And my only tip to you is look at the diagram. If it's marked, you can safely assume it. If it's not, then you cannot safely assume that. Everything else is pretty self-explanatory. You should be able to do these no problem. All right. If you have any questions on anything from the notes, feel free to send me a remind message, or anything about the video, send me a remind message, or jot a question or two down that you want answered in class. Or if you want to go over a problem in class, I'd be more than happy to do that, and maybe get one or two of you at the board to do a couple problems. All right. Thank you. See you guys tomorrow.